For two independent sample t-tests with equal variances, you start by defining your hypotheses, just like you've always done. It may be for equality or for one mean being greater than or less than the other. You specify your significance level. What's new with the t-test is that you need to determine your degrees of freedom because this is needed to define the critical value for significance. When samples have equal variances, the degrees of freedom are simply the sum of the sample sizes minus 2. Given what you've learned so far, would it surprise you to learn that the equation for a two independent sample t-test looked very much like the equation for a two sample z-test? The only difference is that the sample variances are used because the population variances are unknown. Let's look at our cupcake example. Recall that we were interested in comparing the number of cupcakes purchased by men and women during the month of February. In this example, we'll leave the means as 65.25 for men, as 62.09 for women, but we'll change the sample sizes to 5 men and 10 women. The sample variance is 20.15, and for women it's 26.75. Using an alpha of 0.05, do men purchase more cupcakes in February than women do? First, we need to confirm that our variances are equal. Using the process that Wayne showed you, we see that the confidence interval does contain 1, so we fail to reject the null hypothesis. These variances are equal. Now that we have confirmed that they're equal, let's plug this information into the equation. We obtain a t-score of 1.22 with 5 plus 10 minus 2, or 13 degrees of freedom. Looking at a t-table, the critical value that we need to exceed for significance at alpha equals 0.05 is 1.77. We do not exceed that value, so we fail to reject the null hypothesis in this case. There is no difference between men and women in the purchase of cupcakes. Now let's look at how to run a two independent sample t-test with equal variances in Excel.